Now we can give a type checking rule for if then else. So the first thing to notice about if then else expressions is that they do not affect the environment. And if then else neither introduces nor removes any variables from the environment, so all the sub-expressions are typed in the same environment as the entire expression. Now the predicate of the if then else E0, well, that should have type bool because that's our decision whether we're going to take the true branch or the false branch. But then the two branches can have different types. E1 just has to have some type T1 and E2 just has to have some type T2. So notice again what this is saying. This is just saying that E1 and E2 do have a type check. They have to be type correct, but we don't care what the type is. The type can be anything. And then the type of the entire expression is just going to be the least upper bound of T1 and T2 because that's going to be the best estimate we can give to the final type of the expression, given that the true branch might return T1, something of type T1, and the false branch might return something of type T2. The rule for case expressions is the most complex one we've seen so far, but really it's just a glorified if-then-else, and it's relatively easy to understand if we just pull it apart. So let's begin by reminding ourselves of what case does. First of all, it looks at E0, it evaluates E0, and then it looks at the runtime type of E0. So it takes the dynamic class of E0, and then it looks at the first branch. And what is it going to do? It's going to compare the type of E0 at runtime to the type T1. And if T1 is a supertype of the runtime type of E0, and in fact it is the smallest of all the possible branches, it's the smallest supertype of all the possible branches, then it's going to pick this branch, it's going to bind x1 to the value, it's going to give it the type T1, so it's going to bind x1 to the value of E0, it's going to retype it as type T1, and then it's going to evaluate E1. So you can see in what sense it's a glorified if-then-else. We're just picking the best matching branch, the one whose type, declared type, most closely matches the runtime type of E0, and then we're going to execute that branch with the variable that's named in that branch bound to the type of E0. So let's see how the typing works out. So first we type check E0 and we get some type T0. And now what's going to happen? Well, if we select the branch, the first branch, well, then we're going to take the environment and we're going to extend it with the new variable x1, which is going to have type T1. And so we only take this branch, remember, if a runtime type of E0 matches T1 most closely among all the branches. But if we do take it, then we're going to execute E1 in this environment, and we'll get back something of some type T1 prime. And similarly for all the other branches, until finally the last branch, which is exactly the same as the first one, just with the letter N replacing the number 1. And so since we don't know which branch is going to match at runtime, it could be any of the branches that actually executes, and therefore the type of the entire expression is just going to be the least upper bound over all of the types of the various branches. And here I've just extended least upper bound from a binary operation to an n-ary operation. That should be clear enough. We're just going to take the least upper bound over all of these types.